Okay, so what in the world is trig besides a really, really, really scary word? And that's honestly all it is. I want you to forget about that we're doing trig. And I want you to think about we are doing triangles because that's all trig is triangles. We're specifically going to do right triangles. What is a right triangle? Well, a right triangle happens when we have a side squared, so I can put 12 squared, plus another side squared, 5 squared, and that equals what's called the hypotenuse. Oh, big fancy word. It's the longest side, my 13 squared. So how do I know what's what? Well, my sides, check out my sides. My sides make, no, my mouse doesn't want to move, an L. There is an L right there. The sides make an L. So that's what I put on my left-hand side. And then the side opposite the 90-degree angle, the right angle, that's called my hypotenuse. So hypotenuse, big fancy word, has to be my longest side. Has to be. So let's check this out. Is this true? 12 squared, well, if I grab my calculator, I know 12 squared, 12 times 12 is 144. Plus 5 squared is 25. Now, if I add those together, I get 169. Now I'm going to grab my calculator again, and I'm going to check 13 squared. 13 squared on my calculator, is 169. Those are the same. That's how I know this is a right triangle. All we just did was Pythagorean theorem. Pythagorean theorem. And all Pythagorean theorem says is you're going to see it as a squared plus b squared equals c squared. That is the most common way to say it. Or, the way I like to say it, the leg squared plus the leg squared. And remember, those are the ones that make the L equals that hypotenuse squared. Okay, so where does this trig come from? Well, there's ratios. Ratios, all that is a big old fancy word for fractions. And we take and make fractions with the sides. So if I draw that triangle again, it was 12, 5, 13. A, B over here, and C. So if I take my ratios of 5 over 13, well, what happened was millions of years ago, not really millions, but a long time ago, somebody discovered that all triangles, right triangles, had this relationship. So we take opposite this angle with A, opposite and the hypotenuse, the 13. So remember, that's always the hypotenuse. We discovered that it is the same ratio for whatever that angle is. Well, so someone got really, really fancy and they were like, oh, we're going to call that sine, S-I-N, of that angle A. So the angle using this weird sine thing is 5/13. Well, then B felt really left out, and B said, well, I want something. So, well, we can take the sine of B and say, oh, opposite. So I'm going to put my thing at B and I'm going to hike straight across 12. Still over the hypotenuse, which is always 13. Well, that was cool. But what happens if I don't know my angles or I don't know my opposite? What happens if I only know the side right next to A? Oh, well, they found out that there's something else. We call that cosine. Still looking at A. Cosine of A. Well, we're going to go right next to it. That's adjacent over still the hypotenuse, 13. So 12/13. So really, and I don't want you stressing too much about this. I really don't. And it's hard because there's this scary word that's out there but you're doing a small geometry part of what's called trigonometry, right triangle or triangle mathematics. We're just going to do a little tiny bit. So what's going to happen is we're going to give you a triangle, and let's say it's a 3, a 4, and a 5 triangle. And I'm going to put an A up here, a B down here, and a C here. And I'm going to say, hey, what is, say, cosine of angle A? Well, I get really confused with what these mean. So there's a saying. This saying is SOHCAHT, which we haven't really talked about, OA. SOHCAHTOA. SOHCAHTOA. It's one of the most common sayings for knowing our angles. And all that is sine. And sine deals with opposite. Over hypotenuse. Cosine, I'm going to grab a different color just so we can see this. Cosine is adjacent, right next to. And hypotenuse again. Well, then this other thing came along, and there's a relationship between these sines and these cosines, which is called tangent or tan. And that's just opposite over adjacent. Okay, so that's really all I want you to know. SOHCAHTOA. So I'm looking at the SOHCAHTOA and I need cosine. So I need A and H. So if I'm looking at A, the angle right next to it is 3 because this 5 is always my hypotenuse. So cosine of A would be 3 over 5. And then say Miss Gray got crazy and she's like, hey, find the tangent of B. Ooh, tangent of B. Okay, so I'm going to go to my angle B. That's down here. Tangent, ooh, I know that because it's in my thing. It's opposite. Ooh, opposite, walk across. That's 3 over adjacent. Ooh, is that the 4 or the 5? The 4 or the 5? Oh no, 5 is hypotenuse. So it's got to be my 4. 3 over 4. See if this makes sense, and then I can show you how they get the values because that's all calculator. I don't know any of those values unless I push it in a calculator. So see how this does. Let me know. I hope you and Mom are feeling better, and we'll talk to you soon.